Section 5.3, integration by substitution. Sometimes you hear this called U substitution or U sub or whatever, okay? It's another method for integrating. Now, why do we need another method? Because it's necessary. Here's why we need another method. Let's suppose you wanted to integrate something like this, okay? 3x plus 1 squared dx, okay? You wouldn't have a problem integrating that right now. All you would do is you would say, okay, 3x plus 1 squared is 3x plus 1 times 3x plus 1. And then you would multiply that out to give you the integral of what? 9x squared, plus 6x plus 1. And you would integrate each piece right here, okay? Well, that's fine and dandy. But what if I do this? What if I change this slightly and put a 20 up there? Do you really want to multiply this out 20 times? Absolutely not. That's going to take you forever. So this is where another method comes in very, very handy. It's called substitution, okay? And actually what it's doing is it's undoing the chain rule we did with taking a derivative. All right, so let's go ahead and start out with this one. The integral, well, I'll tell you what, let's just stay consistent with the notes here. I have something like this, x plus 3 to the 15th dx. But either way, I don't want to multiply this out 15 times, right? So I'm going to use the method of substitution. Now, what I normally do is I normally look for an inside and an outside function, okay? In this integrator, you'd probably say that x plus 3 is an inside, and something raised to the 15th is the outside, right? And you usually pick u to be the inside. Now, we're going to be more technical in a minute how to pick u. But for now, let's let u equal to the inside. So we're making a substitution. U will be x plus 3. So then let's see what we have. So this is going to give us the integral of, instead of x plus 3, I'm going to put u to the 15th here. Tell you what, let me do this. U to the 15th here, dx, okay? Now I have a big problem. I have u and x's here, right? I don't want that. So I'll go back here, okay? I picked u to be this. Now, the way we work this is we go ahead and we take the derivative of both sides of this with respect to x. So we're going to say du over dx is equal to, what's the derivative of this side with respect to x? Just 1, right? Then what we do is we treat this like it's a fraction now, okay? Like it's du is the numerator and dx is the denominator. And then we multiply both sides by dx. So we have du is equal to 1 dx. All right, so let's go back here now, okay? We have the integral of u to the 15th. But now, I want everything in terms of u and not x. But over here, what does it say dx is equivalent to? Du. So instead of dx here, I'm going to call that du. Now, everything's in terms of u now. How do I integrate this? Well, add 1 to 15 says u to the 16 over 16, right? Plus my arbitrary constant c. But my original function's in terms of x. So I need to back substitute and put this back in terms of x. So instead of u to the 16th over 16 plus c, what I'm going to do now is I'm going to say, okay, we called u what? X plus 3. So I'm going to take this x plus 3 right here, and I'm going to sub it back in here. X plus 3. There's my answer. U substitution. Let's look at our next problem that we have, our next example. We have the integral of x squared plus 3. We have the integral x squared plus 3 raised to the 20th times 2x out here dx. All right. Let me see. What do I do now? You were taught in the last section. Look for if you just have a power of x. Okay? Is this just the power of x? No. So I can't just add 1 to the power, divide by the new power. Okay? It's not going to work here. What was the other thing we were told? We were told if it's x to the negative 1, then that's the natural log. Well, that's certainly not x to the negative 1. What was the next thing we were told? We were told, try to think of something you can take the derivative of to give you that, right? Well, it's not so easy in this case, okay? If it were like the integral to sine, that would work well. All right, so the only other technique I know right now is u substitution, okay? So I'm going to pick a u. Normally what I do is I pick u to be an inside part. If you look at this integrand right here, you could say an inside part is x squared plus 3. So I'm going to let u equal to x squared plus 3, okay? Then we go ahead and we take the derivative of both sides with respect to x. Du over dx is equal to 2x. And then we multiply both sides by dx. So du is equal to 2x dx. Treat that like a... Never mind. All right, so go back to this now, okay? We have the integral. What do we call this part? X squared plus 3. We call that what? U. So we have the integral of u to the 20th. Now how about this 2x dx? 2x dx is also known to be what? Du. So I'm going to call that du. Well, I know how to integrate that. That's just the power of u, right? So I'm going to say u to the 21 over 21 plus c. All right, but my original function was in terms of x. So I'm going to back substitute. Instead of u to the 21 over 21 plus c, what did we say u was? X squared plus 3. There's my antiderivative, or an antiderivative, I should say. So using u substitution. All right, let's talk a little more in depth about picking the u here, okay? I picked u to be the inside. Yeah, a lot of times that works, okay? But technically, here's how we need to pick u. Whenever I'm deciding to pick u, you kind of look ahead, okay? Like you say, okay, if I pick u to be x squared plus 3, and then I take the derivative of both sides, what am I going to get here? I'm going to get 2x, right? Which is what I want to have right there, 2x. Okay, so you try to pick u to whatever you take the derivative. Your variable portion over here is somewhat the same or similar, okay? Now there could be some manipulation, but for the most part, you try to take it to whatever you take your derivative here, a variable portion is the same, okay? How about our next example? Next example says evaluate, then we have several parts, A, B, C, and so forth, okay? Our next example, we're told to evaluate the integral of 3x to the 5th minus 7 times x to the 4th dx. Now, I could actually do this without u substitution like we did in the last section, but we got a new toy, let's play with it, okay? That new toy is called u substitution. All right, what do I want to let u equal to? Usually the inside, right? So let's start out with the inside. 3x to the 5th minus 7. Now, imagine in your head, what if I take the derivative of this? What am I going to get? 15x to the 4th? I have an x to the 4th. It doesn't matter if you have some constant multiplied by that, because you can always take the constant and pull it out. So if I end up having 15x to the fourth, I can take that 15 and pull it out. That's not a problem, okay? So this looks like it's going to work for my value of u. So let's take the derivative of both sides with respect to x. That'll give me 15x to the fourth over here. Then we treat this like a fraction, multiply both sides by dx. So du is equal to 15x to the fourth dx, right? All right, now, what I have here is I have the integral, what I call this part, call that part u. So I have the integral of u times x to the fourth dx. So what I want to do next is I want to go ahead and isolate this x to the fourth dx. I can isolate that if I divide both sides by 15 or multiply both sides by 1 over 15. So 1 over 15 du is equal to x to the fourth dx. I like that representation a little better, okay? So instead of x to the fourth dx here, what is x to the fourth dx also known as? 1/15 du, right? Now, what do we say if we have a constant multiplied by our integrand? What can we do with this constant? We can pull it all the way to the front. So 1 over 15 times the integral of u du. So what does that give me? That gives me 1 over 15. What's the integral of u? That's like u to the first, right? So wouldn't that be u squared over 2 plus c? All right, so what does that give me? 1 over 30 u squared plus c. Technically, I need to multiply that by both of them, but it doesn't really matter. 1/15 times c is still a u constant. All right, so that's 1 over 30 times u squared. Let's back substitute. What was u again? 3x to the fifth minus 7. So instead of u squared, I'm going to call that 3x to the fifth minus 7. Don't forget that plus c at the end, very important. There we go.